It's time for lecture today. So today we have two lectures. We're going to talk about, first thing we're going to talk about files, and then we'll take a little bit break. After that, we're going to take a study about lists and dictionaries, which are two basic data structures. So for the first part of the lecture, we're going to review array a little bit. We're going to introduce file and talk about what file is, and then we're going to talk about some basic operations on a file, which is read and write. And between that, we'll have a little bit administrative break if Casper has any announcement to make. And after writing a file, learn how writing a file, we'll talk about how to locate the file. And I don't think we're going to talk about bonus topic today. But if we have time after the lecture, entire lecture, we'll talk about bonus topic. But we'll see. All right. So array. This looks so weird. Okay. So array. It's a collection of indexable items, and they are usually have instead of containing one data, it can contain multiple data. So, and they have to be the same type. So to declare an array, we need to specify a type. Its identifier, which is the name of the variable, and we also need to make sure that we have this pair of square bracket. Example here, we declare an integer array, named age of students, and a string array which has name table of contents, for example. So however, declaring array doesn't necessarily give us an array. We need to assign it before we can use, access, or read anything from the array. So to assign an array, we need to use the keyword new, and we also need to specify the type of the array, and we need to give the size, and put the size in a pair of square bracket. In the example here, we assign an array of 50 integers to this integer array, which is age of students. And here we assign an array which has type string, contains 20, can hold 20 items, to this array variable we declare, which is table of contents. To initialize an array, basically is a combination of declaration statement and assignment statement. Example, we declare a string array which has name my friend list, and we assign it as an array which has 100, which can hold 100 strings. And very important, you must initialize the array before you can access, read, or write to it. So another important part is array cannot be resized. Once you assign an array, once you assign to it, this array will be the fixed size. However, it can be reassigned, although it cannot be resized. So for instance, in this case, I first declare an array of string which has the size of 20, and then I have some code running here, and then I decide, okay, 20 might not be enough for me. So I assign a new array which can contain 40 strings in it. So, however, if you ever assign anything to this array prior to this statement will basically erase everything you assign to it. So in other words, if you say my grocery list for zeroth item equals to apple, and then when you assign this new array, the item apple will be gone. So, and this is totally you can consider this reassignment as a reset of the array. So all the data you saved. Okay, question?
Wait, but aren't you resizing it there?
it's not resize. In other words, the size is fixed. You cannot increase this size. In other words, so for example, if this I put 20 items in this list, and then I want to add more items to it, I cannot do that. What I have to do is I need to give a new array, or I should copy it with what I have there and assign to copy them to a new array. Another question?
Yeah, what happens if you actually try to resize it? Will it not let you do it?
You try to resize it?
Yeah, what if
You cannot do that. It's, you basically don't have the mechanism to do that. In other words, you don't have the syntax to do that. You will learn how to get a dynamic array in the second part of the lecture when we talk about list. Okay, the good questions. Okay, so how does array look like? When you declare an array, int minus, without looking at the right side of the equal sign, you only get this. You only get this part. You don't get anything here. And then you assign something, which in this case we have 8 numbers to it. 8 numbers in it. We assign an array that has 8 integers in it. And they are all indexed from 0 to 7. In order to access items, we use the index. So for instance, if you want to access the 0th item of this array, we say my_nums squared 0, and this expression will return the 0th item in this array, which is 11, and we assign it to a variable which is int 0 to 1. And in order to modify an individual element in the array, we also need to use the index. So for instance, if I want to change this from 11 to 7, all I need to do is my_nums, specify the index, and assign a number to it. All right, multidimensional array. I don't think we covered it in the past lecture. I don't think our textbook covered this very in depth. So we'll basically briefly go through it. So a multidimensional array is basically an array that contains arrays. So for instance, if it's a 2-dimensional array, we basically have one dimension that is a single array, and for each element, it points to a different array, one-dimensional array. So to declare a 2-dimensional array, you need a pair of square bracket, and you need to specify the first dimension, which is the number of the rows, and then for each row, you need to do another set of assignment statements. So for instance, for the 0th row, I assign a new array to it. So the 0th item in this 2-dimensional array will be a 1-dimensional array with a size of 4. And this one, I assign another 1-dimensional array, which has size of 4, to the second or the first item in my matrix. How does it look like? When I declare first, when I declare the int double square bracket, my matrix, what I got is this. It's a pointer here, points to a 1-dimensional array, and they all point to something null. So that's why we have the 4 here, but we don't have anything here. And then in the first statement, the second statement, I say my matrix 0 equals new int and 3, which I'll get this part. I assign an array size of 3 to the 0th item of this 2-dimensional array. And then similarly, I can assign a size of 4 1-dimensional array to the second item. So the benefit, you can see, as you can tell, they don't have to be the same size. And if you want them to have same size, you just need to change this number to 3 or 4 or 5, whatever you want. Okay, now we're going to talk about files. So, files. Now everything comes with a problem. So in this case, let's say I want to get 100 students' name. What I did was I declare an integer variable, and which has value 100, and then I declare a string array, which has a size of 100, and then for each element of the string, I want to print a prompt here, and I want to read some input from the user and assign to the corresponding position in the array. So the problem is, when the program terminates, where's our input? Where's our input gone? So I enter the 100 students' name while the program is running. I am expecting this to be saved somewhere so that I can use it later. But is the input ever saved anywhere? No, it's not. Actually, when the program terminates, all our input, all of the data in the program are gone, are lost in a void. That's not ideal, because when we write programs, we need to manipulate data, and most of the time, the data are expected to be reused. And if we cannot store our data somewhere in a permanent form, it's kind of like pointless. Why do we do that? So the solution is we store data on disk instead of memory. What's the difference between memory and disk? When program is running, all of the data manipulation are be done on memory, because memory is very fast. Instead of on disk. How fast is memory? So suppose the time that it takes for CPU to get some data from memory is the time that I travel from Chicago to Madison, Wisconsin. And then the time it takes for the CPU to get data from disk is about time from the Earth to the Moon. So you don't want to do that. You always want to manipulate data in the memory. However, memory cannot hold data very well. The power needs to be on, and the program has to be constantly running so that the data can reside in memory. So the solution is we store things on disk. And disk, you can store everything on disk without worrying about the power and the program. Yeah, and on top of that, disk has larger capacity. Typical memory today is like 4 or 8 gigabyte, but the disk you can get like 2 terabyte almost, with a very low price. And that's where we want to store things. So, however, how do we store data on disk? We need to store data as a file on disk. So, in the operating system, file is an abstraction of the sequence of characters. It does not have to be on a disk. It's just a form that we can store data on disk. File is also an abstraction of input and output of a computer. So when you type something on your keyboard, when you move the mouse like this, you are actually writing data to a file. And the computer is reading data from that file and writing data to another file, which is the display, and shown here. Data is usually, in this file, data is usually read and write as a stream of characters. Files can be stored on disk, it can be in memory, and it can be accessed by many programs. For instance, if you have a Microsoft document file, you can open it with your Microsoft Doc, you can open it with LibreOffice or OpenOffice, you can open it with your Apple Work, things like that. And the most important thing I want you guys to know, it may not be on exam, but is that everything on computer is a file. The data, all the documents are files, or your multimedia files, your movies, your songs, your pictures are files. and devices. Monitor, mouse, keyboard, USB drive, everything is a file. What do I mean by that? Those files, especially the device files, they are kept from, they are actually hidden from you by the operating system. The operating system doesn't want to let you know their existence. However, you can still access them. So here's a demo. Suppose I want to know what happens when I move my mouse like this. Well, it turns out that in many Unix systems, mouse are inputs such as this are mapped as a file in the computer system. If I want to display anything in it, I'll need to do something like this. And of course, because it's a file that belongs to a system, and I am not supposed to access it unless I have the password. So now, what happens? There's nothing in it. It doesn't show anything in the file because there's no input to it. However, if I start moving my mouse a little bit, if I move my mouse to the right, you'll see something like this. If you move my mouse to go up, it will go something like this. If I move mouse down or something like irregular things, these are not general characters. They are binary information, basically like 0, 1, 0, 1. And what it does is that the system reads the file, and when your mouse moving something like this, there's inputs will be written on the file. System reads the file and interpret what it does, and then write to the file, which is the display. And then that's how you see the mouse is moving like this. This is basically the interpretation of those whole weird characters. All right. Of course, you don't need to know. You're not required to understand this, but I'm just showing you how files are heavily used in today's computer.
Can you say that our keyboard is a file?
Yes.
You just mean when you type things into the keyboard?
You will see some character like this, and then it's up to the system to interpret what it means, and then give that to certain applications, and they will interpret what it means, and then that's how you see those inputs from the keyboard. Okay, now let's go back to our lecture. So how does a file look like on a disk? It is stored as a sequence of characters. So for instance, I have a text file that contains this part of the content using system public class hello public static part of the program. What it looks like in computer is, in a disk, is that it's stored on a sector of different sectors of the disk. So we start from this here, the outside one. We start with letter U, and then we have letter S, I, N, G, and then there's an empty space character, and then we have a capitalized S system, and then a semicolon, a new line character, and then P character, and then goes to the inner side of this circle, UBLIC, and an empty space character. So this is how file looks like on a disk. When the file is when you need to access a file, the operating system will read as a sequence and load them into the memory as a stream. So that's why it's called file is also called a stream of characters. So there are many kinds of files. Binary files, such as MP3 or movie file, all of those MP4 files, text files, pictures. But the most commonly file that we use is a text file. It's cross-platform. It can be read and write by any operating system. It's just universal. That's the file that we're going to deal with in this course. So the contents in the text file are mostly ASCII characters, meaning that they are mostly English characters and with some punctuations and numbers in it. And text file has no format. What it means is that there's no font color, there's no font size, there's no picture in it, there's no line spacing. It's plain text, like this. There's no data tells you what the fonts should be like. Examples. For example, the program that you have been written so far, .cs file, which is the C# program source file, and Java program, Python, C, C++, and all the data you have, which are mostly in CSV, which is comma delimited file, web pages, those HTML files. If you ever notice that when you go to your web browser, you see something like .html as a text file. And the web browser is just basically interpret what is in HTML and show the graphical part of it. User preference. Most applications save your user preference as a text file, and they're mostly hidden from you. So for example, if I go to my home directory, you don't see anything here other than the normal file directory you have, like documents, download, Dropbox. But if I show the hidden files here, you see all those kind of user preference file. For example, one of my favorite text editor called Emacs, it stores all my preference here. If I open here, you'll see all these things, and this is a text file. And it doesn't have to be fancy. It's just for storing data. Okay, so file. What can we do on a file? Turns out there are two basic operations on it. Read a file, write a file, and that's it. Simple. When we need to read a file, first thing we need to do is we need to load the file from disk to memory, if the file exists. And then we can read the file line by line from the beginning to the end, or from top to bottom. And you can read the file. You can read them, of course, you can read them inversely, but it's very difficult and it can be tricky. So I would not recommend to do that. How to write a file. So first thing you need to do is you create a file in memory. And then you write content to the file that is in the memory instead of on the disk. And then once you finish writing content to the file, you close the file, and the file will be saved by to the corresponding folder in the disk. And one important thing you need to know is that if you save to the file you created in a folder that already has a file that has the same name, the file will be replaced by the new file. So be careful with that. They must be done separately. In other words, you cannot read and write file simultaneously. You don't need to know why right now. You will learn more about it in the operating system course. Okay, so for when we write a program, how do we actually read a file? Before we just talk about how the mechanism works. So first thing is you need to know the file's path, which basically the path, a string that can locate where the file is in the computer. And of course, you can do it manually if you know the path of the file, or you can just do it in the code. You must have the file extension. So for example, when you write a Word document, the extension is usually .docx or .doc. If you're a Windows user, you probably will never notice this, but if you open your change your directory preference, you probably will see the file extension. You must specify the file extension before you can access it. And when we read a file, we need to create a stream reader object for that file. Use the path name we found. And how to create a stream reader object? You use the new stream reader constructor to create that. For instance, if I have a file that is named as myfile.txt, and in order to read it or load it from disk to memory, I will need to do stream reader, and in this case I gave this name as SR, and use this new use this constructor new stream reader, and put the file name here, and this will allow me to load this file from disk to memory. Now we need to read something from the file, so we will read the content of the file by using this .readLine method. So this one will read one line instead of all the lines of the file. So for instance, we create this stream reader SR. We can use this method, use this object to call this method, and this one will return us a string that only represents one line of that file, and we can assign it to a string variable, and then we can print out if you want. And once you finish reading the file, you need to close it right after. So you want to use the .close method to close the file so that your program will not constantly control the file. Okay, any questions?
If you just said read line,
Yes?
how would it know which line to read?
Good question. If you call it in the first time in the program, say you only call first, so let's say this whole thing is your entire program. This will only read the first line by default. Read the first line, and then if you call it function again, you will read the second line. The system keeps track of which line you're writing, which line you're reading, and the number of times you call this method is the number of line you're reading. So if you call it 4 times and then you call the 5th time, you're going to read the 5th line. Make sense?
So if you did return like string line 2 equals sr.readLine, it would read the second.
Yes.
Okay.
So let's see how it works. How can we read a file from disk? So the algorithm is, first thing we need to locate the file path, and we declare and initialize the stream reader object for the file. Question?
So is the stream reader like built into C#?
Yes.
Or C?
Yes, we'll see how it works. If we want to read everything in the file, we can do something like this. While there are still more lines in the file, we read a line from it, assign what we read to a string variable, and print it out. And once we finish this part, or in other words, there's no more characters in that file, we exit this while loop and close the file, close the stream reader object, and the program will end. Okay. So, oops, I accidentally closed it. Here's how the code looks like. In order to use the stream reader object, you need to use this library called system.io besides of using system. And then in the program, you need to get the file name. In this case, I use a command line argument. You don't need to know how to do that right now. And then I create the stream reader object using the file name that I got from command line. And then, while stream reader has character. So stream reader end of stream tells you whether or not we are at the end of the file, and as long as this is true, we can keep reading things, keep reading a line from the stream reader and assign it to a string variable, and we can print it out. Once this is false, means that we are at the end of the file, this while loop will end, and we'll close this stream reader. How does it look in action? So we compile it first. Okay. Now let's see. I suppose I want to print out itself, which is fread_demo.cs. What I would do is I invoke the program and give the argument, which is fread. Oops. And we hit enter. It will print out what the program is.
If you don't have the system.io, is stream reader like useless?
You cannot use the stream reader.
Okay.
So in other words, your program will not compile, and the compiler probably going to tell you you have to import that library before you can use stream reader object.
Gotcha.
Good. So yeah, that's simple. Makes sense to you guys? How the program works? You read a line. As long as there's still more lines in the file, we read a line from the file, which is sr.readLine, and we assign to the string variable and print out. That's how you can display things like text file in the console. Okay, all right. So my question for you guys: what's the difference between console read line and sr.read line? Assume that sr is already declared and initialized properly. What's the difference between them?
Is one dealing with a file?
Excuse me?
And then string input B dealing with a file?
Yes. What do you think?
Oh yeah, like the string input B just it gets its file, it gets it from a file, and the console.read line we get it from user input or from memory.
Yes. So console read line only read input from the console. In other words, you have to, or the user have to type something in order to make this code work. Stream sr.read line, basically it just read a line from the file, whichever the sr is. So this one is fixed. This one can read from multiple files. This one only works in the console. This one you can read anything on the disk. That's the difference. Okay, let's take an administrative break. Catherine, do you have any announcements to make?
I'm trying to get caught up on reading, so I will be fine. I could log into some time, but it'll be caught up. That's it.
Okay, that's short.
You know about the exam next week, will it look like the last hour of our class,
It'll, I'm sure it'll be more conceptual.
So we still do have an exam next week?
I don't even know.
Oh.
Do we even?
I don't know, because I'm not really the official TA of this course, of this section.
I mean, I can send Dr. Koenig an email. I'm just not sure when he'll respond.
He has, that out there in the syllabus, an exam too.
But yeah, I feel like we're not really ready. That's because he's gone. I don't know. I mean, I guess we could. But.
Especially.
Yeah, I doubt if they'll just give it to him when he comes back. I mean, I can't promise you, but I wouldn't
Yeah. Wait, what chapter are we supposed to have read up to right now? Is
You're on the file, which is 9. But I think the array was 10, so you should
okay.
get to 10.
Yeah. Oh, okay. And then, do you know what chapters the exam would cover?
It probably will be covered enough, so probably anything that's covered in the beginning will be.
So like up to chapter 10? Like
Yes.
will it have the lines in it? Or not lines on, what are they called, man? Lists, thank you.
It will probably have a list. Is that what we're covering today?
Yes.
Yeah.
Oh, okay.
You'll be good. You'll be good.
Will you put these?
Yes, all the slides and demonstration programs will be uploaded to Sakai.
Very clear.
Obviously.
Makes a lot of sense.
Okay.
The ones online are like so.
All right. Well,
Yeah, I'm like, just like roll with random things.
let's just take a little bit longer time for the break. I want to show you guys this website called TOB. This is where you can look up the popularity of programming languages today. So for October 2015, this month, we find out that Java is the most popular programming language. And the second one is C, third one C++, and C# is the fourth one. So not too bad, but not too shabby. Python, if you've ever taken 150, I believe, you're in a good place too. PHP, what is that? It's used for web application things. So when you see all those fancy web apps, they're mostly they are written in PHP. And of course, JavaScript comes with PHP as well. For those of you who use Mac, you probably have heard of Objective-C. Probably, no? Okay. Objective-C is a programming language implemented by Apple. It was originally used for writing the Mac OS. Its popularity has been dropped from 3rd to 14th. Why is that?
Compared to last month?
No, look at this one. Swift. It raised from 19 to 15. Swift is a newer programming language that is implemented by Apple that is intent to replace Objective-C gradually. So more and more people are shifting from Objective-C to Swift. So that's why this one's dropping while the other one's going up. So yeah, does the popularity of the programming language matter? No. If you know how to program in C#, you probably already know how to program in Java. It's probably only take you 1 day to learn the syntax difference and all those tricks. There's only a little bit gap between C#, Java, and C, C++. Is that C, C++ you actually need to learn how to manage the program's memory, while Java and C# just takes care of that for you. All right, now let's resume our lecture. Okay, so we talked about how to read a file. Now we talk about how to write a file. So, in order to write a file, first thing we need to do is we need to find the file path. Of course, you need the file extension, otherwise OS has no idea what you're doing. And then, instead of creating a stream reader object, we actually use a stream writer object for the file. And in order to create a stream writer object, we need to use this new stream writer constructor to do that. For instance, I suppose I want to create a file in a directory which is called myfile.txt. Suppose I want to create a file in a directory. What I will do is I will declare a stream writer object and use this constructor to initialize it. Once we have that initialized, we can use the .writeLine method to write content to the file. So for instance, suppose I want to write the first, this is a line of content to the file. All I need to do is streamwriter sw.writeLine and add this thing to it. So this one will be the first, if this is the whole program, this will be the first line and the only line of that file. What if I want to write more things to the file? Well, I just need to call SW write line again and add some more strings to it. Any questions? Okay, let's see how it works. So, suppose I want to implement a console-based text editor. Sounds complicated? No, pretty simple. What we want to do is we want to declare and initialize a string writer object, and when the program is running, we read input from user. And as long as the input is not an empty string, which means user didn't do anything, just hit the enter button, we just keep reading the input from user. And of course, we want to print some prompts if we want. And otherwise, and then we write the input to the file. And then once the input is an empty string, we just stop this program and close the file, and that's it. Let's save the file. So let's take a look. So I have this program called fWriteDemo.cs. I don't think I need to compile it again, but it doesn't hurt to do it. So okay, so what this program does is that it is going to print out some prompt and wait for my input. And if I have ever put some non-trivial input to it, it will save something. So what I would do is, let's do this. Let's remove this hello CS first. What I would do is, let's suppose I want to write a program used by new text editor. So I would do is I would give the name of the file from here and start writing it. So let's write a hello world program in C#. What we'll have is using system, if it's input, now give me lines first, we'll say public class hello.
When you're writing a file, do you not need the system.io?
Yes. I'll show you the code later after this demo. And then I write this public static void main, and I say console.writeLine hello world from this text editor. Okay, and then we close the curly braces, and then if we do nothing, just hit the enter button, the program will close and the file will be saved. And now you see there's a hello.cs file here. Can the program run? The program will compile. Of course, we will do hello.exe, and then we compile this program. It compiles. If we run it, oh, oops. Okay, it's a different program. Sorry. Here, from this text editor. And what is in it? That's what we just wrote from our very simple text editor. How does the program look like? Like this. So we start with our program by importing the necessary library. In this case, we have system and system.io. So yes, if you want to create a stream writer object, you need system.io. And then I get the file name from the command line argument. You don't know how to do that. Then I create a stream writer object, SW, and use this file name that I got from command line. And this, I declare a variable, string variable for receiving the input, and an integer variable to indicate the line number that I have in the file. And then I do a do while loop. I use a do while loop start with printing out the prompt, line number, and read the input from user and assign to the variable that we declared. And then we check if the input is nonsense or something. So if the input has nothing in it, with basically just hitting the enter button, we jump out of the loop. We don't need to do anything. Otherwise, we write the input to the file that we created. And then at the end of the loop, we increment the line number. So the second time the loop iterates, we'll see a different line number. And of course, we can just say, well, it's true. And after the loop ends, we'll close the file so that the file will be saved on the disk. Is it clear? Any questions?
Oh, when you are like assigning, like you do the stream writer equals the new stream writer, and then you have the name. Do you need to put your name in quotes?
This one?
Yeah.
No, because
Oh.
this is a string. It's a string. It's a string variable. It's not a literal value, so I don't need that.
Gotcha.
Other questions? Okay. All right. We talk about that. How to write a file. Now I have a question for you guys. What's the difference between console write line and SW write line? What's the difference? Any ideas? Yes?
One of them writes it into the console, so you see it, and then the other one writes into the file.
Exactly. So console write line always writes the string in the console instead of a file. And SW write line writes whatever the argument is to a specific file. It does not write to the console. So if you try to print out something, always use if you try to print out something in the terminal or the console, always use console write line. Otherwise, if you want to write things to the file, use the stream writer and dot write line. Okay, this is the most exciting part. Console is a file. When you use console.readLine, you actually read a input or you read data from the console file, quote file. When you use console write line, you write things to it, you actually write something to the console file. The difference between console file and stream writer, stream reader is that console is a standard I/O interface for the operating system. It's a special file that is owned and managed by the operating system. You cannot control it. However, files such as stream reader or stream writer, they are files that reside on the disk instead of the and it's mostly owned by the user instead of the operating system. And console does not exist on a disk. You remember that console does not exist on disk. So you cannot find a file that is console on disk. It's only console file is only there when your computer is on, your system is running. Okay, so we talked about how to modify a file, read a file, and now we need to know how to locate the file, how to find the file on the disk. And turns out that we need to understand a little bit about file and its directory hierarchy. So, all the files on computer is stored under a directory. What is a directory? Well, a directory is a special file that has nothing, that has no content in it, but linked to other files. And only files can be read and written, and directories cannot be read and written. So, what does that mean? Let's see, take a look at this. This is my home directory, very typical. It has like documents, downloads, Dropbox, etc. This home directory is not a file, but it points to all those directories. And then if I open my document directory, which is a file that points to other files or links to other files, I see those directories, these directories, and these files are linked to documents. And then I can open more directory if I want. I can open this directory and I see this file is linked to this directory. This directory is linked to this directory.
So are directories files themselves?
Say again, please.
Are directories files themselves?
Yes, they are files, but they're different.
Okay,
You cannot read or write them.
gotcha.
Remember that I talked about that you have to specify the file extension. Directory doesn't have file extension. It's just a data structure that helps you manage files. Okay, so we go back to our slides. So, in order for your program to access a file while it's running, the program has our current working directory, and the program can directly access file in the current working directory. Every running program has its current working directory, and it's decided by where the program is invoked, not where the program is stored. You'll see, we'll explain that later. Programs can directly read and write a file, or can directly access the file just by specifying the file names without any paths that are in the current working directory. Sorry, I'm losing a little bit of voice now. So that's convenient. So the program can always refer to the files that is in the current working directory. But what about the files that are not in that directory? Because we have so many directories. So we have two ways to do that. We can use an absolute file path or a relative file path. So suppose this is a typical file system. We have a root directory. We have a home directory that has 2 users in it. And we have other system directory, bin, dev, and sys. We don't care. So both user A and user B have their own document directory, and each of them has their own bin source and program A and program B. So in order to find a file, we need to specify its path. So the absolute path will start from the root directory and go all the way to a specific file. For example, if I want to find the absolute path of this program A.cs, we'll have /home/user/A/document/source/program A.cs. That's the absolute path. You have to start from the root. And it does not depend on the current working directory. So you can always use that path regardless of where your program is running, regardless of where the program is stored. You can always find this file by using an absolute path. Relative path is a little bit different. It starts from the current working directory, and we can use that to point to other and use the directory structure to find other relative directories. For example, if I invoke my program A in this directory, and this will be the current working directory, which is root /home/user/document/bin/. So that will be the working directory. If I want to read the content of this file, besides of using the absolute path, we can do something like this. We can go from bin to documents, and then go to source, and then find out where program A is. It's a little bit maneuver, but it's easier. compared with root using the absolute path. The advantage of using absolute path is that you can always find the file, regardless of where the current working directory is. Advantage of relative path is that if you know this part is relatively fixed, you don't need to know what this part is. You can just always go to bin, go to documents, go to source, and go to find this file. You don't need to care about anything here. So in other words, if I use relative path to find this file, and then I move this directory from one computer to another computer, I can still access this file because this part didn't change. So I can always use the relative path to find this file. However, if I use the absolute path, and then I move this whole directory from, say, Linux to Mac, or from Linux to Windows, and then because this part changed, I can no longer find this file, if it's so close. So system files mostly use absolute path because they're systems, they're relatively fixed, they don't care. Application files mostly use relative path because they do not want to be dependent on the system. So how do we find out the file path in the current working directory? We just introduced how to find the file path by using absolute and relative path. How do we find out the current working directory? It turns out that in C#, oops, now this. In C#, you can use importing the system IO library, and you can use this one function, directory.getCurrentDirectory, which will give you the current working directory. And with that, you can figure out where your program is invoked, and then if you want to access some files that is like in nearby sibling directories, you can use the relative path. You will definitely use this in your later project. When you do your grade file project, you're going to read text files from those other directories, and it's important that you know how to find those files using relative path. Okay, question?
What does the current directory consist of exactly? Like, how do you make it or edit it?
It's just where the program is invoked. Okay, let me do a demo here. So, let's see. Right now, I am in this directory. /home /yhole /insync Loyola fall 2015 blah 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 lecture01 demo. This is where I am right now. And if I invoke the program, which was the current directory.exe, it should give us the same thing, right? Because we're invoking this program in this directory. So this will be the current working directory, which is exactly where we invoked this program. So another example what I can do is, let's see, if I make a copy of the program, read here. If I make a copy of this program from this bin directory to this directory, then I want to read this file. What I would do is let's read hello. Okay, let me think. What should I do? Okay, let's see. I want to read hello. I don't need to specify any relative path because this program is invoked in this directory. It can see all the files in this directory. So the only file it can see is hello.cs. So I just need to say hello.cs. However, can this program see this file? No. If I try to do that, if I don't give a relative path, I will get errors. So the only way that to make this program access this file is to give the relative path of this file to this program or to the current working directory. So what I will do is specify that it is under src directory, and then I give the array.demo.cs to print out something. Okay, let's print out the file. So that is you need to be aware of when you do the create file project. All right. Any other questions? Okay. So a little bit summary. So today we talked about array and its operations. We talked about how we can create an array, declare array, and assign to it. And we know that we cannot resize it, but we can reassign it. And we learned a little bit about how two-dimensional array look like, how it works, how do you access individual element. Well, I don't think we covered that. We talked about the difference between memory and disk. Memory is fast, but it's volatile. Disk is large, it can hold a lot of things, but it's very slow. We talk about files. We know this files an interface. Excuse me. File is the abstraction of sequence of bytes or characters. We learn how to read a file by using the stream reader object, how to write a file using stream writer object, and the current working directory. Relative and absolute path. I'm losing a lot of voice right now, so I think we should take about 10 minutes break, so that you guys can refresh and I can recover a little bit. But yeah, we'll come back around, let's say 5:30. Okay. Zoom lecture. So the second part of the lecture today, we are going to talk about lists and dictionaries. There are two elementary data structures that we are going to use for this course. And of course, you can learn more about data structure in the next course, which I don't remember the numbers, but it should be called data structure. Okay, so the plans for this part of the lecture, we're going to skip the review of file I/O. We just covered it. We're going to jump into lists.
Could I ask just one question
Yes.
about file I/O?
Yes.
When we had to specify the path in the last homework that was doing Friday night, that was an absolute file path, right?
Okay.
I mean, or was it a relative file path?
I think I'm not grading your homework, but for my section is that as long as it looks like a file path, I don't really care. I mean, it's like everyone have their own computer systems. They may use different folder structures, so it doesn't really matter as long as the program compiles.
So how do you tell a program whether you're using the absolute file path or the relative file path?
What do you mean by how to tell? Like how to?
So if you knew where like your, I don't know, file you were referencing was in your current working directory, would you just type dash filename dot
Okay,
text
so
or
in C#, I believe there is a way that you can actually so search a file path by a given string. You can actually do that. I don't know how exactly it works. Otherwise, usually in applications, what they do is they just keep a relatively stable relative data folder structures so that. But most of the time, they refer to files in the relative path instead of absolute path.
So to use it, we would just do dash and then continue as if we had typed this stuff before.
Yes. You have to go up or go down and go to stapling library, stapling directories. Yeah. Okay, so we probably won't have an administrative break just because we don't have much announcements to make. Basically, it's just list and dictionary, and then we're going to do lab. These are reviews. We don't know that. We don't need to know that. Now we talk about list. New problem. Suppose we want to read this file, and we want to read the data from it and manipulate the data in the memory. So in this program, what I did was I created a stream reader object. I estimate that there may be 1,000 lines in this object, so I create a string that contains 1,000. Create a string array that can contain 1,000 strings. So I basically start reading lines from the file and assign it to a corresponding location in the array. So the problem is, does this code work? Where is the major problem? What is the ideal size of the array? So let's say if the file only contains 5 lines of string, is it not a waste that we use 1,000 line, like takes 1,000 spaces for the string? Or if my file text has 10,000 lines, then we can only read the first 1,000 lines, right? So in this case, we don't know what exactly the size of the file is, and we cannot estimate when we write the program. And plus, using array is not very good in this case. So, solution is we use list. List is a very primitive but heavily used data structure in computer science. It contains a sequence of ordered items. They are all ordered and indexed, and it is based on array, but it has a dynamic size. In other words, the size can increase as demanded when the program is running, and it can decrease if you want, and you do not need to specify the size. You can always assume that the size of the list, or should I say the maximum size of the list, is the maximum memory you have on a computer. So if you have, let's say, 4 GB of memory, and you basically can have a list that can contain 4 gig of integers, yes. So to create a list object, we need to specify the type of the list that we want to use. This constructor is a little bit different from what we had before. Before we just say new stream reader or new int square for array or for stream readers. This one we need to not only specify that we're creating a list, we also need to give a type in this what's kind of bracket? In this bracket, I guess? Carrots. Okay, thank you. For example, we declare a list, and the item in the list are string, and we give an identifier, which is my list, and we assign a list object to this identifier by using this constructor, new list string. What can you do with a list? Of course, you can get the size of it. You use the .count property. So for example, if I say mylist.count, it will return the size of the list. For right now, since when I declared it, I just say new list. I didn't give anything to it. So if I have a code like this, it will give me a 0 because there's nothing in the list. So the size of the list is 0. We can add item to the list, so which will be appended to the end of the list. And the method we're going to use is the .add method. So for example, my list is a string, so I can only add a string to it. So in this case, I add a hello string to this list. Now there's one item in the list, which is the string hello, and the size of list will be 1. And then I follow up with this statement. I say my list add world. So now there are 2 items in the list. The first one is hello, the second one is world. And of course, we can also remove items from the list. What we'll do is we'll need to use the .remove method. We can remove the items in the list in 2 ways. We can remove them by the index of them, or we can remove by matching them. So for instance, for the first one, I remove the first item of the list. And remember, list is a 0-based data structure index. The index is 0-based, means it starts from 0 and go 1, 2, 3, 4. So in this case, when I say my list remove 1, instead of removing hello, I remove the world. So there's only 1 item in the list, which is hello. And we can also remove it by matching the item. So when I say my list remove, I want to remove the first instance of the string hello. So of course, right now there's only 1 string in the list, which is hello. So this one, once this is removed, there's nothing in the list. What if there are multiple copies of hello? In that case, only the first one will be removed. In other words, it's the one that has the smallest index will be removed. Do you have questions?
Yeah.
Okay.
So for the mylist.remove1,
This
what
one?
What if you had a list of integers? Like how would it tell the difference between 1 as an index and 1 as an integer?
That's a good question, and my answer is I don't know.
Okay.
I'm sorry. Not a C# expert.
Yeah,
If you put the quotes around the 1, then it would remove the 1.
Excuse me?
Like you see what I mean? If you put the quotes around the 1 and the 1 was in the list, then it would remove the 1.
Okay.
From the list.
That's good to know. What's your second question?
Second one was further beginning when you talked about arrays. So I know,
Array.
like in this PowerPoint,
This one?
back
Here?
yeah, there.
Okay.
So I know you don't want us to use this method and it's bad, but what would happen if you tried to read a file with more times than you had lines? So like if you have like 5 lines in a file,
Okay.
but you say to read it 1,000 times, what would happen after?
Yep, that's another problem, is that you don't know. You thought that you have about 1,000 lines, but then you just keep reading it, and you, in other words, you just don't know the size of the file, and that's a problem, right?
So would it give you like an error?
Yes,
or,
that will give you an error.
So it won't complete.
The program will read a little bit, and then crash.
Okay.
Good questions. Now, okay, second part of list operation. Of course, we can look up the index of something. For instance, so what? Oh, there's a typo here. My bad. Okay, there we go. So we use the .index of method to find the index of an item in the list. In this instance, since we already removed everything in the list, when I say my list.index of hello, what should it return if it's not in the list? It gives me -1, which means it's not in the list. What if I didn't remove anything? What if I didn't use these things where I just add hello and world? And then this index of hello should return me a 0, because hello was added first in the list, and there was nothing in the list before hello was added, so it was in the 0th place in the list. Okay. Access item in the list. We can use the index. So let's say I want to access the 0th item. in the list, I just use my list bracket square bracket and put the index in there because it's 0 based. So if we want to access the zeroth item, we use 0, or I should say the first item we use 0. To access the last item, we use my list. And then we count the side of the list, which is mylist.count, and -1 because it's 0 based. So in the last item, the index of the last item instead of is mylist.count, it's mylist.count -1. This will give us the last item in the list. Assign value to the ith item. So we can do things like this. We can just say, I want the 0th item to be world, or the first item to be 1. But of course, you're going to be careful with that, since that you may have a list. You may have a list of 5 items. You probably cannot do that for the 6th item. In other words, you have to add a 6th item to it before you can assign anything to the 6th item. If you want to get the value of the ith item, you just use this one, this expression, which will returns the 0th item of the list.
Sorry, what do you mean when you said that you had to add a 6th item to?
Good question.
Like, are you saying if your list is only like 5 items long?
So for example, well, actually let me see here. Here, okay, I have this one.
Mm-hmm.
So when I first declared this Fibonacci list, which is n, I created a new list. What I got is this, only the left side of this picture, nothing here. So there's no things you can do. There's no items. If I try to say Fibonacci square bracket 0 equals to 1, I cannot do it because there's nothing here. There's no space. What I need to do first is I need to add items to it. In this case, I add 1. I got 1. Add another 1 because there's 2 items here. Add 2, 3, 5, 8, 13. And now, if I want to say Fibonacci bracket squared 0 equals to 12, I can do it because there is a 0th item in it. If I say Fibonacci squared, let's say 0, 1, 2, 3, 4, 5, 6, 7 equals to, let's say, 28, I cannot do that because there's no space allocated for the list yet. So you need to be careful with that statement. Yes, that's a little bit. Yeah, just be careful with this statement. Unless you know how many items you have already added to the list, then don't use this statement.
Would like the compiler give you an error, or would it just be like a silent error?
It will be a runtime error.
Okay, it'll give you a
So compiler cannot check it for you. If you run out of index while the program is running, the program will just crash. Any other questions? Okay. So this is how list is implemented. Every time you add something, you add it to the end of the last item. So when you add 1, so this is nothing, just pointed to a list. And when you add 1, when you first call the statement Fibonacci.add1, you add it here. And then the second time you call it, you add it to the end of the last item, which is here. And then you just keep appending two things. Do you want to, if you ever want to insert something, you can, but that's, yeah, you can insert things if you want, but it can be slow, just that you know. If you want to remove something in between, yes, you can. It's not that slow. Yeah. Any questions?
Something about sort.
Okay.
Did you go over that, or was that?
Oh, sort, yes. You don't need to know how sorting, how list is sorted, but you just need to know that when things are sorted, it's easier to locate and find them. So for instance, if I want to say the index of this statement, say my list index of hello, if I have, let's say, 2,000 strings in it, it's not sorted, it can take a lot of time to find it. However, if it's sorted, before you try to find the index of it, it can be very fast. It's just to give you guys a little bit like idea how sorting can be a big factor of the program efficiency. Okay.
So wait, does it automatically sort items in alphabetical order, or do you need to specify?
Good question. For string, it's sorted as alphabetical order. For numbers, it's sorted from smallest number to largest number. What about other things? It depends. Numbers and strings are the only two things that you guys need to care about right now. So what's the difference between list and array, and what's your, let's make a comparison of them. So the size of list can be changed while the program is running. You don't need to specify the size of a list before you run the program or before you compile the program. It can just change dynamically. For array, the size is allocated while you're running your program before the program is compiled, and it cannot be resized, but it can be reassigned. Speed, they're about the same time. So if you say, well, you guys probably don't care about it. When you guys taking the algorithm class and data structure class, you will know that list has different implementations, and some implementations allows you to access the list very fast. Some implementations will be very slow, but different implementations have their own advantages. When to use the array? We write a program. When you know your program, when you know the data size is kind of fixed, for example, you know that you're only going to deal with 10 numbers, then it doesn't hurt to use array. If most of the operation is reading and writing data, you probably want to use the array instead of list. And especially when the data size is fixed. So in other words, like 10 integers, 20 strings, and especially when you know that ahead of time. When to use list, when you don't know what exactly the size of data. So, for example, if you have an application that try to receive, store the number of, store the orders from customers, then you don't know how many customers are going to order things. So you may have 10 orders or 20 million orders. So you probably want to use a list instead of array. These things, this slide, I think it's good for you guys to know, but I don't think it's required for the exam. Actually, I probably should say that ahead of time. About 40 or 30% of the things in my lecture is not required for this course. I just think it's good for you guys to know a little bit more about the information. Okay, now it's time for us to see how this works in a program.
Can you put an array in a list?
Yes, you can. You can put array in a list. You can put a list in an array. Yeah. Okay, so I don't think I can recall what this program is trying to do, but it's a string. Okay, all right. So here. Okay, so for instance, let's say I want to use a list to receive some strings and sort them. How can I do that? What my program will do is I can put some strings like hello, world, and hi, blah, whatever, oops, some random string and sort them. What happened here is what the program received is in this order: hello, world, hi, blah, whatever, oops. And after the after the list is sorted, it's sorted alphabetically. Remember, it's a string. So we'll have blah, hello, hi, oops, whatever, world. And it also prints out where each item is at by the index. So hello is at the index of 1, which is here, after sorting. World is index of 5, which is here, 0, 1, 2, 0, 1, 2, 3, 4, 5. And hi is at index 2, blah is at index 0. How does this program look like? Pretty simple. So again, I use command line argument to get the input. You don't need to know how to do that. What I did was I declare and initialize a list object. Use this constructor, new list, and then I give the name my list. And then for all those command line arguments I put there, which are these are command line arguments. I add them to the list. Then I print out a prompt saying before sorting, and then I print out the list. And then I print out a prompt saying after sorting, and then I actually do the sort after I print out the prompt. And then I print out for the list after being sorted. And then I print out new line, basically separate things. And then after that, I say for each item in the command line argument, I get the index of the item in that list, use the .indexOf to find out the index of each command line argument I put there. And then I print out the item and its index using this format string. And what my print list function does is that it takes a list of string as an argument, and for whatever is in the list, so from 0 to the end of the list, I print out them in separate lines. So when the program runs, it reads this command line argument, puts them in a list, and then print out them before it's sorted, which is in exactly the same order: hello, world, hi, blah, whatever, oops. And then after sorting, they are sorted alphabetically. And then my program prints out the index of each item I pass to it. Any questions? Is it clear? Good. All right. Since we don't have much administrative things today, so we're going to skip this break. We're going to talk about dictionary. So next, another problem, bounded data. So suppose we want to manage a phone book. We use list. We already know this because list is more flexible than array. So we create a list, two lists. One is name, one is phone numbers, because list can only contain one thing. So we say now we want to add someone whose name is Tom Smith, and this guy's number is 101, 101, 101, and it works, right? It's not bad phone book, but what's the problem? There's a problem here. What if I have two contacts that have exactly the same name? They are both Tom Smith but different numbers. Is it easy for me to look up the number? I mean, yes, I can. I can try to find first time Tom Smith. I got a number. I say, oh, it doesn't look like that case. So I try to find the next Tom Smith, but it's not very convenient, right? Not what we want. What's the solution? It's called dictionary. Dictionary contains two fields, key and a value. Key and value in dictionaries are paired. They are often called as tuple. And key and value can be different type. So if I have a key that is string, the value can be int or double or boolean. Or if I can have a key that is int, and then the value can be boolean, double, or string. Doesn't really matter. They can be different type, they can be the same type. The key in a dictionary is immutable. What does it mean? Suppose you have a key. Let's say it's Tom Smith. You cannot make Tom Smith a different one. So you cannot say it's Tom. You cannot assign it to, or I should say you cannot mutate it. In other words, you cannot say Tom Smith, the variable Tom Smith equals to Tom Hanks, whatever. You cannot do that. But the value can be mutable. So if you have a key, you can change the value, you can do that. The good thing about dictionary is every key must be unique in the dictionary. So for our phone book example, we have two people whose names are Tom Smith. And the solution by using dictionary is I can say first Tom Smith is from Wisconsin. I say Tom Smith parenthesis W. And then the second Tom Smith from Illinois. So I say Tom Smith parenthesis I. Problem solved. We can easily tell the difference between them. But in other words, you cannot have two tuples that have the same key. So in other words, if I want to solve the problem of two Tom Smiths, I cannot just put two Tom Smiths as a key to the dictionary. But I can have Tom Smith A, Tom Smith B, and have different numbers, which phone numbers associated with them. So disk dictionary operation. So to create a dictionary, we need to use the new dictionary constructor. We need to specify a key type and a value type beside of its type of dictionary. So for example, we can say dictionary age, so people's age. We can say string and string represent can be used for their name and int be used for their age. And we can create a new dictionary like this. Or we can do some more things. We can say we want to find the people's age and their income, try to do some data analysis. We can create a dictionary that has their age, that has their income. Suppose we only have 99 people, so that we don't have duplicate keys. To get the size of the dictionary, we use the dot count, which is a property of the dictionary. So in this case, we say my dict dot count. This expression returns us an int, so we can assign it to an integer variable, which is size. And we can also get all the keys for us to and convert them to a list so that we can get all the keys and we can look them up in the dictionary easier. What we can do is first we declare the list, which is a string, since I think my dictionary. Okay. I don't think I specify what my dict is. Let's just assume it's some string, or actually it's string int. So we declare a list, has a string type, and we create a list by using this constructor, new list string, and you need to give something to the list when you try to get the key. So you need to use myDict.keys to get the key, and then pass this to the constructor. The constructor understands what you're passing to, and then create a list for the key. And of course, you can do the same thing with values. So you can just create a list, declare a list, and then use this constructor and take this argument to convert all the values into a list. Why do we want to have keys? Because we want to look up values. So you want to access the value, we need to have the key. So to access the value, we use something that is similar to an array operation. Instead of using an index here, we just use the key. We give the key, and it will give us the value that is coupled with this key. Yeah, assume that in my dict is declared initialized as this. Okay. All right.
Could you do like the reverse? Could you use a value to specify a key?
What do you mean by you want to like search the key by its value? Yeah. Is that what you mean? Okay. That can be a problem. Do you remember that we talked that?
The same name.
No. Do you remember we talked that you cannot have the same key in the dictionary, but you can have the same value. So in other words, if you can do that, I believe you can only get the first key instead of the. For example, if you have 5 Toms, let's say different Tom Smiths, or different people but have the same number. Let's say that you're going to get the first people instead of the rest of the people. Okay, so how do we add items to a dictionary? We add item to a dictionary. We always add a tuple, which means we always add a key and a value to it. So and also we use the .add method. So in this case, we use my dictionary object, invoke this .add method, and give an argument, Tom and 99. So, and yeah, assume that we have my dictionary is string and int. So the first one is always the key, and the second one is always the value. And in order to remove a tuple from the dictionary, we just need to remove the key because all the keys are unique, but their values are the same. So we just remove the key. We can use the .remove method on my dictionary object. In this case, my dict remove Tom. It will remove Tom and 99. So this entire entry will be gone. What does it look like in the dictionary? This is how dictionary looks like in the computer. When we first declare is the first line, dictionary string int tuition, for example, like this. We only get the left side of this picture. And then we say tuition at state A 40,000. We'll give this part and append to here, append at the end of here. So we have state A, which is the key, and the 40,000, which is the value. And then third line, we say tuition at state B 30,000. what we'll do is we create this tuple, which has a key state B and value 30,000, and append to the end of last tuple. And similarly, we do the rest of it, state C and state D. When we remove it, for example, we want to remove state B, we just say tuition does remove state B, and this part will be removed, and this arrow will point from here to here, and yeah, and this arrow will be gone. If we remove state B and state C, this part will be removed, this arrow will be pointed here, and this arrow will be gone. Any questions?
You said sequences, like lists are like the first value, the second
Yes,
value.
they are all ordered. Yes, they're all ordered.
For the dictionary, is it typically a string for a key and an integer for the value?
No,
No.
this is just examples.
Okay.
Yeah. Actually, if you think about dictionary, it's more like a string and a string. You have a word, which is the key, and this definition, which is the longer string. So it's more likely to be a string for actual dictionary. All right. So now some demo time. We're going to use dictionary featuring file I/O. We're going to combine them together. This is probably what you guys are going to do for the project, but this demo hopefully can give you guys a little bit idea of where to start. Suppose I have a grade file like this. First column is they're all comma separated. First column is the name, first name of the student, and then the second column, all those numbers are their, let's say, their exam grade, and then the third column are their homework grade. Let's say exam has like 60% weight and the homework has 40% weight, and we want to calculate the average of each student, the average grade of each student, and then save that to a file. What do we do? Actually, let's run the program first. Bin dictionary demo.exe. Wait a second. Wait a second. I think it's this one. No, it doesn't look like this one. Okay, we'll do a simpler one first. I don't remember what I'm doing here. Okay. So we have exam grade. Alright, so let's say we have let's do a simpler one first. Let's say we want to calculate the average of a class, average grade of a class. Let's say we have Tom, grade is 99, and let's say Mary, grade is 199 as well. Oh, that doesn't really help. Let's see, do this. And then that's it. The class average will be 98.5. Fairly easy. Do we need to use dictionary in this case? Nah, we don't. We don't have to, but it's just a demo. So what I did was I declare a dictionary object which has a keys as string type, and the value is int. And we use this. I declare string and int to receive the input from the user. And then I start print a prompt to read the name of the student and read the input. And if the input is nothing, we'll just get out of here. We don't need to do the program anymore. Otherwise, if the input is not an empty string, we will print out another prompt which we want to get the grade, and we parse whatever the user input is, and then we add this name and grade to this dictionary we created. Okay, now we want to find an average. What we do is we start with a variable double average, and first thing I did was I get all the integer in the values and add that to this average, and then I divided this total grade by the number of students in the class. That's how I got the average grade, and then it's printing out the class average. We really don't need to use dictionaries in this case. It's just really simple, but it's a starting point. Okay, now we go back to our complicated one. This part. So suppose we have a file like this. We want to calculate the average grade for each student. We will definitely need a dictionary, which can be very helpful. How the program would look like. Let me see. Let me just remove the output file first. Oops. Now the output file is gone, and we have this grade file, grades.txt, and what we would do is, my program would do is dictionary. Okay, my bad. I gave the input file name, and I say I give an output file name. It will do it for me. What is in the output file? It's exactly the same thing. So what my program did was, oh, by the way, I didn't even mention this at all. To use list and dictionary, you need to use this system.collection.generic library in order to use list and dictionary. So in both cases, I use the system.collection.generic.
So to use list too?
Yes, for list or dictionaries, you have to use this library. Again, my command line argument receive the file names for me and create a corresponding file reader, stream reader, and stream writer for them. And then I also declare a dictionary object which stores the student's name and the grade. And these variables are there for me to make the program run a little bit faster. It's not really necessary. So, and then I specify the exam weight is 40%, homework is 60%, and then the double final grade. What I did was, this is the main part of the program that you need to understand. While there's content in the file, which is the stream reader, I read a line from a stream reader, which gives me like com 93, com 98, Mary, com 99, 98, etc. And well, the first thing I did was I find the name of the find the name, the index of the first comma, index of the first comma, which allows me to find the name easily by using substring. So what I did was I find the index here, the first comma, and then I use a substring to get the name here. And then for the rest of the substring, I did the same thing to get the second index, which is here, and then which allows me to get this substring easily. And then I can read the exam grade. And then for the rest of the string, I don't need to do anything. I just need to find this substring and parse it to the int. So this is what this part doing so far. And then for the final grade, I use the weight and the grade of each category to calculate the final grade. And then at the end, I add the name and grade, string and double, to this dictionary we declared, which is string and double grades, new dictionary, string and double. Alright, so that's the input part. So once the input is over, we can close the stream reader so that we don't hold the file all the time. And then I use a for each loop to get the keys of each one, to get for all the keys in the dictionary. I print the key, which is S, and the grade by using this grade square bracket S to get it. But this one I print in the console, and then I print it to the file, so that I can see the result in console and file at the same time. And once this part is done, I close the file, and the file will be saved on the disk, and that's what you'll see in the output part, which is exactly the same as the output part. The output file is exactly the same as the output in the console. Does this make sense to you guys? Or do you want me to go through again? Oh, good? All good? Okay. Alright. We have a summary today. We didn't review any files and its operations. We already covered early. We talked about this, the list. We can add and remove items in the list. We can look up items in the list. We can sort it. And for dictionaries, we know how to create it using the dictionary constructor. Add a key, add a key and a value to it, and remove the key and value from it, and get the side of it. That's pretty much it. In Catherine, do we have labs today? Okay, alright, well, I think it's for the rest of today's class, we're going to have lab. I'll be here. If you have questions, feel free to ask. Yeah. All of lectures are recorded, so they'll be uploaded to Sakai. Actually, they'll be uploaded, not necessarily to Sakai. And all the slides and demo programs will be uploaded to Sakai as well, right?